Right, so in this session we're looking at bearings, and I've had to copy out, but not accurately, the question that you will have in front of you. So my answers are going to be different to yours, but I'm just going to show you how one works this all out. Okay, now with bearings, there are three things you need to remember. It's kind of, I call it the 3, 2, 1 of bearings. And the 3 stands for, you've always got to go from the from. That's always important. You've got to go from the from. So if it says go from, that's where you start at. Second one is once you've done that, you look north. So you've got to start looking at the north, and they give you a north scale like that. And then finally, the one is clockwise, because when you do it, you measure clockwise, that is as the clock turns around that way. And if you remember those three things, then that will really help you. So for this I need a ruler and I need a protractor. Okay, it's really important that you get these. These are really, really important. I've also got a scale that says 1 centimetre is 5 metres. Now it might not be the same answer as what you've got, but I'm going to show you how to do it here. So the question says, a helicopter flies in a straight line from Leek to Donhampton. So from here to here. How far does it fly? Right. So what I'm going to do is measure, and in mine it's 10.2 centimetres. So for my one, it's 10.2 centimetres, and I know for every 1 centimetre it's 5 metres. So I times that by 5. Again, if you don't feel comfortable, use your calculator, and it says 51. So I know that it is 51 meters. Okay, so that's my answer for the first part, 51 meters. That doesn't look very good, does it? Let's write it out here. There you go, 51 meters. Then it says, write down the bearing of Donington from Leek. Oh, okay. So what I need to do is I need to draw that line from Donington to Leek, and as it says you're going from Donington, oh no, from Leek. There you go, see how I can get it wrong? It says, what is the bearing of Donhampton from Leek? So from the from. So I now here look, I go from the from, look north, so I'm going to point it up north, and then I'm going to go clockwise. Now the other thing is you need to remember is if it's the angle is less than 100, you put a 0 in front of the number. It's always 3 figure. So here you can see it's 150 degrees. So it's a bearing of 150. And don't forget, if the bearing was over here and it's say 80, you'd have to say 080. So just be aware of that. And that's how you do bearing questions. They will come up. It's quite useful. It's quite handy to know how to do. So then we get to the next part of it. It says here, now let me see if I can read this out correctly because it's pretty titchy. I've got 2 points, A and B. Hello, Pam. Let's just do that again. So I've got A and B. There's my A and my B is there. And they've got the north points pointing up. Like that. Like that. And then the question says, the diagram shows the positions of 2 people, A and B, who are on their Duke of Edinburgh expedition. Good on them. And it says the bearing of C from A is 062. Now it's hard to actually read that, so I think it's 062. So I'm going to draw a line between the two. Obviously this is not drawn to scale, never trust them. They'll always say things like not drawn to scale as well, so just be aware of that. So it says the bearing of C from A. So the bearing of C from A, somewhere around here, is 62 degrees. So get my, that's my north line. So it's 060. So 062. Boom. There. So it's off at that point. So it's going off there. Oh, here's my ruler. And so they are somewhere along this line, somewhere along that line. And then it says, gosh, the sun's shining. It then says that the bearing of C from B is 275. So 275 from B. Now obviously my protractor only goes to 180. So I've got to think about this. If it's 275, okay, how do I do that? Well, I know that 275 is going to be, if that's 180 degrees, that's 270. So it's going to be somewhere off here. Okay, somewhere off here. If I could work out that angle there, I literally go back from 0. If I could work that angle there, and I wonder if you can work it out, because we do know what all the angles around a point equals, and we also know what that equals there. So yeah, if I do 360, take away that, I should be able to tell me the remaining point. Okay, and it tells me it's 85 degrees. So I'm going to do now an angle or a bearing of 0.85 from this point here. Make sure my 0 line is along the north, and it's 0.85. So I'm going on the inside, 0.85 there. And then I do a mark, and you can see where they cross. That must be where C is. So C must be there. And that's how you answer that one. Okay? And then it says the last one, work out the bearing of B from C. So let's write the question out. There's my north line, should really use a ruler. That's pointing towards B. There's my A, and it says that ... and this is 50 degrees, and they want the bearing of B from A. So go from the from, look north, clockwise, all of that. Well, we know that's 180 degrees, add another 50, that's my bearing, 230. So hopefully that has been helpful. Do we have time to squeeze in that one? Yeah, we do. Let's just do that as well. So it's using scale. So let's just try this question. It says here, a map has a scale of 1 centimetre representing 50 metres. So I can write it in a ratio form like that. And then it says, put a circle around the ratio which is equivalent to. So it is ratio. Now obviously this is centimetres, this is metres. So actually I can go all the way back to that stuff I did earlier on here. See how powerful this is. And I'm going from, because I'm going to change it, one or the other, it doesn't matter which one. Let's just change the metres to centimetres, because the question is 1 to something. So I want to go from metres to centimetres. I need to times by 100. So times that by 100 to convert it to centimetres. So that means chuck 2 noughts, boom. And now because they're all in both centimetres, same units, like I say, it's 1 to 5,000. And that one is on there. And then it says, question says the distance between two shops is 4.5 centimetres on the map. What is the actual distance? Well, if I look, okay, you can see I'm going to go from 1 to 4.5. How do I do that? Well, I times by 4.5. 4.5. So I can times 50 metres by 4.5. And that would do it in meters term, which is pretty handy, because you'll probably want it in meters, the distance, not centimeters. Silly. So times it by 4.5, and I get 225 meters. So that's how far the shop is. Great. Hopefully this has helped.